automatically let people in?
You can when you're doing, sorry, this is Sam Miller from Aurora. When you're setting up a meeting with outside people, there's a little banner that says, make sure that everyone can bypass the meeting. I can send that in the chat.
Oh, okay. Nice. Thank you, Sam. Mm-hmm. All right. So
and you have to advise everyone that you're recording as well.
Oh, yes. This meeting is recorded.
There you go. Good job.
Thank you, Jess. That is the appropriate thing to do. So this is the second stakeholder meeting for Volume 3 updates. And we are specifically talking about grass buffers and grass swales today. And Brick, do you want to go ahead and share your screen? I sent out the agenda and we're just going to do introductions. We're just going to do introductions through Poll Everywhere. So if you haven't used this, you can either get into your phone, or if you have a second screen set up, you can log in through your computer. So at the top of the screen, you see a site. Hey, Brick, will you put that in the chat too? So people can just copy it and paste it.
All right. Here we go.
Oh, sorry. That means you had to get out of your PowerPoint, huh?
Yeah. You could. That.
But we'll just do introductions this way. So once you get in, just type in your name and where you work. Is it working or not working? Maybe it's. Has anyone typed in their name? Yeah. Oh, okay, there we go. Thank you, Andrew.
My fat thumb's typing on my phone.
Part of this is just giving everyone a chance to make sure they're in. So when we ask other questions, you're ready to go. And we do have a few from the consultant team in this call. So Andrew Earls with Wrightwater, Tracy Bolger with Muller, Jim Woolleman, Muller, Jess Clark, Stream, very enthusiastically. And also a few from the district. Did I miss any consultants that are part of the consultant team? Okay. Looks like we have 25 on the call.
Wow.
Pretty good.
It's also good because there's the free version of Poll Everywhere maxes your responses at 25. So.
Oh, it's perfect. All right. Well, you can keep adding those. when I sent out this invite, I asked if anyone had something that they wanted to share, an experience that they wanted to share on grass buffers, grass swales, or level spreaders, or anything related to the criteria in those fact sheets. And there were 3 people that indicated they wanted to share. And so I'm just going to invite Morgan Lynch to share your screen. This is, you know, the stakeholder meetings, we're really excited to hear from everyone before we start drafting sections of what you feel is missing or what experiences you've had with the existing criteria or lack of criteria in some cases.
Okay, well, I'm going to try to do this. I'm going to admit something is, I feel like my control button is like stuck or it's like not liking me, but we'll get through it. So I just wanted to share just 2 examples of level spreaders. Nothing in particular is awesome about these things. But I just like the idea of level spreaders, so I've been trying to implement them. I know oftentimes I feel like our guidance might be lacking. I think Holly shared with me when I was in the process of designing both of these, I believe it's the North Carolina guidance on level spreaders. And so I passed that along to both consultants to consider when designing these. So I did 2 different level spreaders at Sterling Ranch on Sterling Gulch, which was a fee and lieu project. And mainly the reason for that was Douglas County requires 100-year conveyance in their storm sewer. And so we're getting a lot of flow that comes out of these pipes. So they're rather large pipes. But, you know, usually you're just kind of dealing with some base flow. So is there a way we can slow the water down before it gets to the channel? And so this one was really based on that North Carolina guidance, and I'll try to zoom in. I have some pictures too, but the site's still partially under construction with the development adjacent to the stream. But anyway, so you just kind of go into here. You have a little lever spreader, diversion weir, a launching pad, and then just a swale down to the channel. So nothing crazy about that. It is a long level spreader, and I wish we designed it. I can't remember what we ended up designing it based on that North Carolina guidance. And I'm sorry, Holly, I meant to look into it. If we wanted the details, I can pull it out. But we assumed like a certain amount of flow for that water quality or the minor storm event, and that's kind of how we sized the level spreader. And so I do have some pictures
based on like a 2-year.
Yeah, I think it was, yeah. So like I said, my pictures aren't great. The site's still being developed up here. This is, since it was a fee and lieu, we put in the flared-in section and the level spreader, and they're still supposed to be putting in the pipe. So there's been some issues with that, and it hasn't really functioned yet as designed, because you can see this part of it is still under construction. But this is what it looks like, and the thought is that under a minor storm event, everything's kind of coming down here and then sheet flowing over. You can see there was some site maintenance that didn't occur, and so this was all backed up with sediment from this pipe installation, and so some sediment went downstream. But that's essentially that one. I hope to get better pictures of this once this is one we'll keep monitoring once the site gets a little bit further along. And then the second one I wanted to share was more of a retrofit. This was on Marston after the project was complete. I don't know if I have a great picture of it. There was this street where there was a culvert, and it was already kind of a dead end street, but we formally removed the culvert crossing and opened the channel up. And in doing so, I think like a lot of engineers, we underestimated the amount of flow that's coming off the street. So the curb and gutter traditionally went into an existing inlet into that culvert crossing. When we removed all that, we just put in like a riprap rundown to kind of capture the flow off that curb and gutter. But we were already seeing erosion occur at that location before construction was complete. So I thought, let's try to retrofit a level spreader. So this one wasn't designed with, we kind of looked at water quality and what we could do, but it was more of a retrofit with, can we do the best we can to slow the water down, spread it out, and reduce the erosion along the overbank. That was the overall goal of that one. So this one's a little different as well. We ended up, I don't know if I can zoom in easily. Again, I'm having like computer issues, but I'm gonna mess this up. You can see the little notch here. We have water coming off the gutter down this way to a little notch. Again, we have that kind of splash over the weir. I guess some decent pictures of this one. Again, this one just got constructed as well, so I haven't been able to monitor it yet. But you can see how we kind of captured the flow off the curb there. It's also got a trail connection, so we were able to kind of do that. This is the end of the street. And then this is the notch that we kind of landed on to contain some of that 2-year volume. So we'll continue to monitor this one. This one will be a little bit difficult because of where it is on a dead end street to maintain. It's going to have to all be by hand with routine maintenance. But since it is a dead end street and there's no houses along here, hopefully we're not seeing a whole lot of maintenance. But those are just kind of the 2 that we did.
Nice.
So
did that second one, you were just working with the area that you had. It's not sized.
No, we kind of looked at what were the different flow events and the water quality events and things like that. But no, it really wasn't sized since it was kind of a retrofit to just kind of to fit it in the best we could.
Yeah.
I have those calculations available, but I know we really weren't able to achieve much here.
Okay.
So is there rock under the grass and blanket on that slope?
Yeah,
Okay.
so there's rock all the way down. And that was a comment that Holly made, which was a good one. So we just originally had rock here and rock here coming off the gutter, but we ended up removing everything there and putting in the soil riprap and blanketing and revegetating for the whole.
It was kind of an alternative to putting in just a outfall into a channel.
Yeah.
Right, just spreading it out.
Yeah, we had to do coming off the water is rushing, and I can share with this group maybe after the fact some of the calculations, but the water is just rushing down this curb and gutter. There's a pretty good slope on this street, and that erosion that was already happening with just regular events was kind of crazy to see. So we knew it was going to be a long-term problem. And so if we can spread it out and maybe achieve some water quality, why not try?
Or at least not cause erosion.
Right. Not cause erosion, slow the water down. I was like, it's at a dead end street. Nobody really notices it. Yeah, so I thought it was a good place to try to retrofit.
Looks easy to maintain too. Just the guy with the shovel or
Yeah.
a person, an employee with a shovel that can go in and just scrape it.
Yeah, it wasn't as, as elaborate as is it the Denver Bay where they can kind of do the clean out mechanically. Anytime you have to have manual labor doing the clean out, you got to consider that. But I guess like Andrew said, it's better than dealing with erosion problems in the long run.
Nice. Thanks for sharing
Yeah,
that. I know.
sorry I don't have the specifics on the calculations. I can get that back to the group though.
Oh, that's okay. One of the things on that first example is that we didn't have, we really don't have guidance in the manual. We don't have good guidance in the manual on level spreaders. And that's something that we want to add. And part of the challenge is when you have, 100-year pipe coming in, how do you peel off just a portion of that, right?
Right. And sometimes it just doesn't make sense. Like we have another pipe upstream and they were talking about a level spreader, but it was a 72-inch pipe with 200 CFS coming down. I'm like, there's no diverting here.
Right.
1,000-foot level spreader.
Yeah, it's very contextual, which is why I think guidance on level spreaders is sometimes difficult.
Megan, did you want to share
Sure.
as well?
Yeah, so I have experience with a few level spreaders and grass buffers lately. Let me see if I can share my whole screen and not just one. There we go. So one level spreader / grass buffer that worked out really nicely was in the SEMSWA district. I worked with Tiffany on that, and that was more of an open channel like we just saw, open air, you know, just like an open gutter. And that worked out really nicely. This is a Duraslot example. So this is on the Auraria campus, and we are picking up these 2 roof drains, sending them underground, and then this right here is actually the level spreader. This is just a rain garden, but well, you might notice that they used the wrong type of mulch. We did make them fix that. But one of the problems is that they actually buried the slot. So this is not a great picture, but this is it up close. So this is that slot, you know, placed horizontally. They did not do a great job of keeping the concrete out of that slot. Obviously, they used some large riprap, which we did spec to be kind of, you know, a riprap pad where this spills out, but they didn't use the proper bedding underneath to really support that. So, you know, we weren't super pleased with the way that that came out. We've been trying some different detailing as we move forward with, you know, new designs, but I think that would be helpful to, you know, just try to address the construction detailing of these level spreaders. That was more or less utilizing a detail that looked something like this. We have since added a concrete slab, which I think is mentioned in the runoff reduction spreadsheet, but not in the level spreader or grass buffer details or criteria. So that might be something to consider if that is something that we want to move forward with as a part of the criteria.
Yeah, there is currently a little bit of a disconnect with the volume reduction fact sheet and the grass buffer and grass swale fact sheets, just because of the timing of those. And
sure,
we're aware of that.
Okay. Yeah, but overall, you know, we did find it pretty simple to identify the size requirements of the grass buffer. You know, there's a lot of good info out there. It's really just getting that level spreader design figured out and figuring out how to get it constructed correctly. That has been a challenge.
Okay.
Particularly kind of the Duraslot example.
How long has that been in place?
Probably 2 years. So this was just a picture from our punch walk. So I haven't been out to look at this particular system in a couple of years.
Okay.
Yeah, it's right at Spear and Auraria, right on the corner there. So you can probably even see it as you drive by.
Holly, this is in that part of one of our sites too. This is one of the sites that we identified too, just because the vegetation connection with fire attention as well. Yeah.
Nice. I know, I think Tiffany's on the call as well. Did you have any experience with this one, Tiffany, that you wanted to share?
Sorry, this is not the one that we did with Tiffany. I unfortunately don't have pictures of that one.
Okay.
That one worked out well.
Right, because
we're happy with that one.
This one's at Auraria. Right?
Yep.
Okay.
Was this for roof drainage primarily?
It is, yeah. So these lamstones are collecting the roof drainage. Then we have an inlet just below them, which then is collected in a pipe, which leads to the Duraslot pipe that's, again, placed sideways through here.
Is there any pre-treatment if you get trash in that inlet?
There is not. It's only roof drainage plus that, small inlet. It is we use like a pedestrian grate, so no treatment there. The other version of this, which hasn't been constructed yet, but we just designed, is also roof drainage. And that just seems to be sometimes the most difficult to collect and treat. So I think level spreaders are a good way to do that, but it does usually mean that we're collecting them in pipes, to take so that they don't run across sidewalks or for various reasons.
Yeah. All right, thank you, Megan. Cassie, I know that you sent me, is Cassie on? Oh yeah,
Yes,
see
I'm
you.
here.
I know you sent me pictures, but did you want to share?
You know, I don't have too much to add, but I am never gonna miss the opportunity to share a pretty picture, so I can pop one up. And I did think of one additional thing that I wanted to kind of touch on.
Okay, great.
A second here. Hold on.
That is pretty.
Right? So this is the SumSWA office demonstration garden. So this is technically, you know, more of a bioswale with a slotted forebay, but a lot of the principles kind of cross over. But one specific thing that I kind of wanted to touch on with the grass swales is mowing. That is kind of a consistent issue that we hear about at this particular site too. It's, you know, every year we go through the same conversation with the maintenance team and with the SumSWA team of what the best procedure is for mowing versus not mowing. And, you know, obviously that's going to be pretty site dependent. If you're doing a grass swale in a bluegrass turf area, then the answer is, you know, you're going to mow it most likely. But this one is intended to be a little bit more native looking. So the hope is that it doesn't get mowed frequently, but that's just an ongoing discussion that we have to keep having with maintenance crews. So I think the moral of the story might be to get an understanding of the goals for the project before, you know, you get to the point where you're out there fighting off the lawnmower.
Good.
Mm-hmm.
Okay.
That's about it.
Thank you all. I want to get back into the poll everywhere questions that gave you some, and I emailed out some questions this morning that we would be asking. So just in an effort to hear from everyone, Brick, if you want to bring up that first question, or the second question, I guess it is. What is your biggest challenge with grass buffers and grass swales? And this could be with regard to design, construction, or maintenance, or so slope, is that not having enough slope, or is there, for whomever wrote slope, if you want to expand on that, I invite you to do so.
Sorry, that was me. I thought I was unmuted. That was Hines. I was saying, yeah, slope is one of the hardest things when I was doing design was just finding areas that we had shallow enough slopes that we could use grass buffer.
So you could meet the criteria?
Yeah.
And it was going, yeah, so so it's considered as a water quality and step one.
Yeah, and honestly, just to keep them to keep them as grass lined even.
Yeah. So on that, and right now in the criteria, we have some guidance on putting in check structures, and that was something that came up with consultants. Do we need more with regard to, as far as concepts for check structures in a grass swale? That would help with slope.
Yeah.
perhaps we could consider a steeper range of slopes than the current criteria as well.
Yeah. Yeah, part of our intent with this update is to provide some additional flexibility. All right.
That recent one definitely relates to performance too. And Holly, when you're talking check structures, are you talking like, say you have a 200-foot long grass swale, putting something halfway in between to kind of create a multiple system, or?
The way that it's presented in the criteria right now, it's about reducing the slope so you can better meet the criteria. So if you have a strong slope, it's not gonna, it won't meet criteria in the fact sheet.
And
Yes.
criteria meaning runoff reduction or water quality.
Well, so this
Swale criteria.
is the swale criteria, and it's important now to note with the new permit that people are designing grass swales for different reasons. So right now it's presented in the criteria to meet step 1 of the 4-step process, just to minimize directly connected impervious area. It is not presented, it was never presented, you know, in 2013 as a standalone post-construction BMP. You would have treatment after it. And then with the phase 2 MS4 permit, there is a volume reduction design standard. So we added T-0 so that you could use a grass swale to calculate volume reduction. And it is possible to use a grass swale in that way to achieve your post-construction requirements. And then what has come up is that people are also wanting to use it under the pollutant reduction standard. So I see a comment here on levels of TSS removal. And I don't know that, I mean, I've had some conversations with Jane Clary looking at the International BMP database. I don't know that we would be able to put out a design so that you could put in a grass swale and meet the pollutant reduction criteria in or design standard. So that is to say that there are lots of different reasons why people want to use grass swales, and we will do our very best to provide good guidance on all of those. That should be in there, yeah. All right. Hey, Brick, will you go down to some of the very early entries? I just want to see if we want to discuss any of these. And if you provided a comment and would like to elaborate on it, please just go ahead and unmute yourself and speak up.
Well, Holly, this is Andrew. I added the comment on the density of vegetation for native non-irrigated areas, and I think somebody else has a similar comment above related to irrigation or lack thereof and vegetative growth. And I think that's one of the struggles, is that it's fairly easy to get a grass buffer right if you're using turf grass and irrigating it, but if you're using natives, it's a lot harder to get that uniform surface or uniform dense vegetation. It's a lot easier with the natives to have, you know, some bunch grasses in there or other things, and then before you know it, you really have a lot of preferential flow around the plants instead of through them. And so one of the things that I kind of wondered is, you know, I know that we reference volume 2 for the seed mixes in the re-veg chapter, and that's pretty reasonable. But when you go and look at those mixes, I wonder, and I'm not a landscape architect or an ecologist, so I will defer to those on the call who are, but it seems to me that for water quality and stability, it probably is better if we could go with more of a monolithic stand where you're not going to get preferential flow paths, even if you're using natives. And I don't know if something like buffalo grass would be the right candidate for that. Again, somebody else would know more about that than I do, but that is, you know, in a lot of cases, where we've run into using substations actually in a number of places is around substations. where they're creating only a small amount of impervious area, and then they're essentially using the buffer to not have to build a bigger post-construction BMP for a few hundred square feet of disturbance. So in those areas, they're typically not irrigated. And I think that's been a question we've been asked some, and it's a challenge, I think, just from other buffers I've seen too, to get real good dense native vegetation.
Yeah. Yeah, and kind of going back to those permit standards, so that there's different criteria for different uses of grass swales. So if you're going for volume reduction, it does really need to be good 80% coverage vegetation. And then you saw a level spreader, which was really bioretention. Megan, what you showed was bioretention, but don't we want to also have guidance on different landscape coverings for a grass buffer? Sometimes, and Morgan showed one as well, where she put in riprap.
Yeah.
There's value in spreading out flows, so.
Yeah, no, I agree. I think the more options we can have, the better. It's just the main issue I've run into is just the density of the natives. And if that's going to be the problem, then you may be smarter using rock or something else. I mean, stability is first and foremost, spreading the flow is second, and then whatever you can infiltrate is kind of third.
Yep. Understanding long-term maintenance goals of vegetation. Incentivizing design and examples where grass buffers, swales has worked. One of the things that I've seen as we've helped local governments update their own criteria is just putting in a requirement for MDCIA. Documenting runoff reduction. So is there a specific challenge related to documenting runoff reduction that someone wants to speak to?
Yeah, that was mine. So most of the work that I do is within the city and county of Denver. And Denver provides its own challenges when it comes just to the availability. But I guess it's kind of a rare site that we can actually see a benefit to utilizing grass buffers and swales when it comes to actually reducing the size of a pond or whatever detention unit that might be. So we've kind of gone through the runoff reduction spreadsheets, but it just hasn't really actually resulted in anything tangible or something that we could sell to our clients in order to get them to dedicate that space to grass buffers or swales.
Got it. Okay.
Holly, one comment on the runoff reduction is that I think that the runoff reduction method is really well suited for grass buffers, but perhaps less so for the volume reduction calculations for swales. Obviously the buffer at sheet flow and you've got the 4 cover model for that, but with swales, I wonder if either the runoff reduction spreadsheet could be used for that, or the other way that we've looked at it before working with Jim Woolleman is to look at kind of a constant loss model from the swale. So, it's basically you figure out your hydraulic residence time, you figure out your saturated hydraulic conductivity, and then based on the wetted area, you figure how much water would infiltrate. So there may be a slight, I don't know, and this is a good question for the group, but is there a need for a different way to quantify it for swales? Or like Megan was saying, does it really not even matter that much? And then the last comment that I would add in, Megan, based on what you said, which was a really good comment, is I have found a lot of times that when I'm using, the infiltration rates from the runoff chapter based on hydrologic soil groups, and I think Jim's had the same experience, that you may be really underestimating infiltration that occurs during small events, because a lot of those runoff coefficients and infiltration rates for Horton's method, those were really developed to be conservative for flooding purposes, not to actually model what the actual infiltration is. So that's another thing that I know I harp on from time to time is that for small storm hydrology, we might want to be using, well, ideally you'd be using measured infiltration rates on the site, but I think you may not be getting enough credit for infiltration if you're using the rates from the runoff chapter.
And what I heard you say, Andrew, was maybe if you are trying to calculate runoff reduction really for grass swales, the way that we modeled our work going into T-0, we could do that differently for grass swales.
Yeah, I think it's a little different. It may not, it'd be something that'd be pretty easy to look at, Holly, to see if it even makes a difference, or if you count the swale area as your receiving pervious area, maybe you'll get the same results. But on Oak Gulch, for example, where we modeled it in SWIM, what we did to account for losses in swales, which were smaller than some of the other losses we had, but we used a constant loss model. And, if you assume, that you have saturated hydraulic conductivity, you won't overestimate it, but using a good saturated hydraulic conductivity value and the amount of time that it's going to be wet, you can get an estimate for the volume that would soak into the ground as the water flows through the swale from a design storm.
Mm-hmm.
And I think, Andrew, you make good points, and we can follow up afterwards. And Derek had some involvement in that, and certainly Holly. So personally, I think it's set up okay for swales. T0 is, but we're using quite conservative the A, B, C, D Horton's infiltration rates, and like you say, on small storms, those can be very conservative. And so maybe the next area of exploration is those infiltration rates, but we can do that with you offline.
Yeah.
Okay, are there any other comments? Rick, I don't know if you want to pan down that anyone would like to speak to here. I don't know if I can help you with irrigation, but the criteria just say that you need at least temporary irrigation for establishment. Okay. All right, let's go to the next question. All right, so what is missing right now with regard to grass buffers and swales? What are we missing? What should be added or emphasized in a stronger way? And I'll just give you a couple minutes so you can think and type. Let me just ask this. Has anyone typed in anything? I'm just wondering if we're having technical difficulties. In the past, in the past stakeholder groups, it's been, there's been more interaction. And I don't remember seeing that radial dial. Okay, there we go. Thank you. Oh, so maybe we're not missing anything, or maybe we've already talked about it. Okay. Okay. Well, we'll just keep that slide up in case you want to add anything, but I will share with you some comments that I've received via email. More options for level spreaders. Absolutely. Yes. I want to explore more concepts there. And there were some comments, in the last question about vegetation and help getting vegetation established. And I'm not sure if everyone is aware of the topsoil guidance that we just put out, but we just did a good amount of work with Jim Williman, who's on this call and part of the consultant team here, and Muller, and on topsoil. And so there will be good references to topsoil and how we prepare grass buffers and grass swales and just areas in general for vegetation. There was a comment on, right now we specify this vertical differential in the grass buffer of 1 to 3 inches. And the comment said consider 4 to 6 inches, just from a standpoint of maintenance, which is could be significant depending on how you're constructing that. And maybe that one would be good just to provide that flexibility. I wonder, this comment came from Tiffany, and maybe Tiffany, you could clarify where you've had problems with that. Has there been a concrete lip? Or was that an area where your vertical differential was dropping from pavement down to landscape, and over time that distance kept getting smaller?
Hi, Holly, it's Tiffany. Those are typically in like parking lot areas where we are dropping from a parking lot directly into a buffer or swale.
Okay.
And as the water goes into the swale or buffer, it drops sediment, and then what happens is it starts backing back out into the parking lot if not maintained.
Yeah.
We did recently update our levels, some of our level spreader details to have, I think, a 4 to 6 inch drop. So we'll start hopefully seeing those go in here soon.
Okay. Yeah. So it sounds like you didn't, if you look at our criteria manual, we have this concrete lip on the downstream side of the slotted curb detail, which helps establish that vertical drop a little bit better. But if you don't have that, you can lose the vertical difference pretty quickly. Okay, and the other comment which I mentioned was, needing guidance for using grass swales in different ways, be it MDCIA, volume reduction, pre-treatment for regional water quality BMPs, so the 2010 rule. We need to address all of those. Use in a larger treatment train. So is that a question about how to essentially get better credit for grass swales?
Yeah, that's what I was thinking, Holly, is, how do you, it seems to me if you want to encourage the use of them, there's got to be a bigger benefit to people.
Right. Yeah, we've heard that. It gets a little tricky because as you implement treatment train, as you implement BMPs in series like that, you get less efficiency as the water gets cleaner. And so it becomes kind of a complicated calculation to provide, but it's definitely something people are wanting to see in there. Okay. All right. Well, on this one, Morgan mentioned criteria from North Carolina, which is something that I've given people when they ask me about better sizing for grass buffers. On this one, we've put some thought into it, and we've talked about things that could potentially change. And Andrew, do you want to share your screen and go through some of the slides that you prepared?
I would be glad to. Just a sec. Let me get over on the right one. And this isn't too fancy. No colors or showy presentation, but I'll show you the ones that I have here. And just for the group to know, what I did is I kind of went through the fact sheets for grass buffers and grass swales with a real critical eye and tried to add a bunch of questions, and then I kind of tried to boil it down. And a lot of these are going to be things that we've already discussed. And again, I just preface this by these are just kind of brainstorming ideas and some thoughts, and that I really would like the reaction from the group on. Kind of and I'll go through each one of these in a little more detail, but, and this is not comprehensive, but my list was, for potential updates would be quantification of runoff reduction. Well, I think we have that in the runoff reduction fact sheet. There may be some nuances to it, and it may get into kind of those infiltration rates that I was just talking about. The separation level between the buffer and the pavement, again, that's the issue Tiffany had mentioned. Sheet flow versus concentrated flow equations, minimum buffer length, the minimum width of the interface, and then getting into the concept from North Carolina State University, what is the maximum buffer length? The longer the buffer is, and the further you go down it, the more of a chance you have for the flow to concentrate, and you're not using all of your buffer. And then there's the item I mentioned on the non-irrigated buffers, level spreaders, and then the design example. And so let's go through each of these, and what I'll do is I'll kind of pause after each one, and we'll see what the group has to say about it. But so in terms of runoff reduction, I do think, I guess a few of the thoughts that I had is that number one, the runoff reduction tab does the job. But you do have the issue of what's the appropriate infiltration rate to use, and from a number of projects I've worked on, I think those hydrologic soil group based rates are very good for flood control engineering, but I don't think they tend to give enough credit for low impact development and infiltration at the small storm level. So at the 0.6 of an inch water quality storm, probably up to the 2-year storm. And the other runoff coefficients are probably good to use above that. But below that, you really want to be a little more accurate, I think, with the way that infiltration is represented, and collect data on site is all the better. And then the final thing I had, which is also related to the infiltration rates, was the idea of, what are the effects of irrigating an area, on the infiltration rates. And, you could almost see where, and I don't know, again, just thinking out loud, but where, if, normally what you do is you do like a Horton curve, right, for the a buffer or a swale. And maybe the thing is if you're irrigating it and you don't have a smart irrigation controller, maybe you should just be using the saturated rate instead of the initial decaying to the saturated rate, because, for all we know, it could be irrigated and sopping wet when it rains. I don't know if we need to go down that road, but it's an idea. And then, the non-irrigated can also have issues with infiltration too, though. If it really dries out and gets hard and cracked, you may not get very good infiltration on those either. So I guess those were a few of my thoughts on runoff reduction. Any thoughts or comments from the group or other ideas? Has anyone on the call applied the runoff reduction tab to size a buffer or swale? Well, come on, I'm sure someone has.
Or maybe you tried and decided it wasn't, you weren't getting enough credit.
Yeah.
More of the latter, yeah.
Yeah. It is much more effective for grass buffers because it's not concentrated. You have you typically have a much larger area.
Yeah, I found it to be very helpful. I've done a couple of buffers that way, and I like it. It does a good job of that. Well, those are, and you don't need to feel like we have to have an answer to this today. I'm just throwing ideas out there, and certainly, if anybody has ideas they want to share after the meeting, obviously email Holly and copy me, or vice versa, email me and copy Holly, and we'd love to hear your thoughts on that. But in the interest of time, let's move to the next one. The next one is really, well, two items here. The separation between the buffer and pavement, which we just discussed, and so we don't need to dwell on that. My thought, I guess personally, is that the 3 inches seems about right, but the 1 inch seems like it might be a little low. And that's really mainly only based on the fact that I know my yard grows more than an inch between when I mow it. So I don't know if the lower end of that, as Tiffany is suggesting, might be bigger. Of course, if you get to too much separation, then you have to worry about erosion. So it's kind of a fine line. And that's a good one. And then the other one are the sheet flow versus the concentrated flow equations that we use. You know, those are based on this kind of dimensionless, well, I guess it's not dimensionless, I guess it has units of feet, but for this criteria where you multiply the watershed flow length times the interface slope normal to the flow. And if it's less than 2, you have sheet flow. If it's more than 2, you have concentrated flow. And Holly, I was curious, do you know the origin of those equations?
Yes. Yes, I do. Okay, so this is how criteria works.
Ben made it up 30 years ago and we're still doing it. No.
So sometimes there is research and studies and research that we can go to that helps inform equations like this. And sometimes you just have to pick a number and go with it. And so that's what we did 11 years ago or whenever it was that we made this decision, because we needed to provide some guidance on how do you know when flow is going to be concentrated, and we weren't able to really find anything good on that. So we went with a number, and then we looked at that again after we had some experience with it and fine-tuned it. And that is the origin of those equations.
Perfect. Well, that's good. Those are the best numbers where you actually have real experience, where you've dialed it in. So that may not be something that needs to be updated at all. I would put this in here just to raise the question and to see if anybody else had any experiences with that. And it sounds like you do, Holly. So, okay. Well, that's that. I mean, I think we look kind of critically at a lot of different things. This next one is one that I do think, oh, I know one other question. Just let me raise this on the last one. And this is an equation for those who've applied this a little more. But I know that this equation is based on the watershed flow length and then the slope that's normal to the direction of flow at the interface. And I guess one question I've kind of always had about this is, I mean, so you're calculating, you want it to be sheet flow at the interface. And I guess the question I had is, does it make more sense that you, well, and not only do you want it to be sheet flow at the interface, but you also want it to be sheet flow on the buffer. So should you be applying this equation to both the interface and the buffer, or the parking lot and the buffer, or is this truly, Holly, something that you all have really calibrated to be based on the interface slope?
No, the interface slope, if you can imagine a parking lot that generally drains to a buffer, but maybe it also has a little bit of a slope along the interface, you may still have sheet flow, right?
Yeah.
That's all we meant by interface slope.
Okay, I got you then.
Yeah.
Okay, well, that makes sense. And if these criteria have been working, then there's no reason to change them. I mean, I'm a firm believer in that. If it's not broken, let's not try and fix something that seems to be working well. Okay, now these are two criteria that I think maybe are ones that could be on the table. And one of them is the minimum buffer length. And that value in the criteria currently is 14 feet. And that's pretty, that is based on a literature that was from around 2004. So we've had another 15 years of research since then. I think I did a search maybe about 5 years ago. And if I remember correctly, I think that it showed, the literature review at that time showed diminishing returns, with the length beyond about 5 meters. And this is for water quality, really, water quality treatment. And so that number may be current, but it would be an easy enough one just to check in the literature to see if there's anything more current than Barrett's study. And then the second question I had about that kind of minimum buffer length is that it really is a treatment-based approach. You know, and I think for volume reduction, you know, it's probably similar, although you could get volume reduction benefits potentially with a shorter slope. It's just that you're not going to get a lot of water quality benefits for having a buffer longer than that. And then I guess the other thought would be is, you know, with the buffer length is, do you want a longer minimum length if you have a non-irrigated buffer with vegetation that's not as dense or for whatever reason that's not going to have quite as much straining or filtration as an irrigated turf grass stand. And then one of the things that I really liked about the grass swale section is it has this text box in it, I think, that kind of says, hey, if you can't meet the criteria entirely, you know, don't let that discourage you. You can do it anyway, and you'll still get some benefits. And I think that the, you know, the runoff reduction spreadsheet has really opened the door to do that a lot easier than it ever was in the past. Oh, hang on, sorry about that. Darn it, I'm trying to silence this thing. Anyway, sorry about that. And then the bottom one, this is where we start to get into some more of the NC State stuff that we may want to consider. You know, this is the minimum width of the interface is defined with this empirical relationship, dividing the 2-year flow by 0.05. And again, if that's working well, we may not need to change it. But the way that NC State does it is that they really look into the maximum buffer length. And right now we don't have a maximum buffer length in the criteria. It's really a minimum length. And what this illustrates, this is from Bill Hunt at NC State, and I think this is what Morgan was referring to earlier, and Holly had actually sent this along as well. And the idea that's shown here is that you have your level spreader in kind of the greenish color, and you have good sheet flow as it's shown here. When you first cross over the buffer, you hit that kind of apron area. But then as you start to get down in the buffer, I mean, it's what happens in a natural watershed too, is that the further you get down the slope, the more you start to have concentration. And this really illustrates it in terms of what they're calling the effective distance. And it's really about trying to take advantage of the whole buffer area for infiltration. And I think that the method that, well, there are a few different equations for this, but I think the crux of the method that NC State uses is that it's related to the permissible velocity of flow across the buffer and at the interface. And I think they have limits, maybe 3 feet per second or something is what they recommend. And I think that's something we could look at here to see if it makes sense to derive some criteria in a similar way. Bill Hunt, for those of you who know him, does excellent research. You know, the one thing we probably need to be a little careful about in Colorado is just that our vegetation's not always as healthy as it is back in North Carolina. I mean, certainly if it's irrigated, it will be. But for some of the natives, it may be a little bit of a different scenario where your velocities would need to be a little lower. Or obviously, if you had a steeper buffer, that would be the case. But this is a really interesting concept, and it's I don't have the governing equations in here, but it's really not very calculation intensive. It's something you could do on your calculator, not with a model. And it's something that could be done in a model very easily too. So anyway, that's one idea. And I think that NRCS has some guidance as well. I mean, there are a few different things out there, and I think part of what we're hoping to do as a part of this update is to really look at what's out there and figure out, you know, if we don't like what we currently have, then what else is out there that's been peer reviewed and practiced and works that we can borrow. So I don't know, I know, Morgan, you mentioned that you have some experience, or you've directed consultants to this to evaluate it. Did you get any feedback from the consultants on how easy or complicated, or did they like the method? Did you get any feedback at all?
Yeah, this was the method we used out at Sterling Ranch, and it was relatively simple and easy. I think the challenge there was the 100-year pipe, right? But yeah, no, I'm interested to see how it works in the long term to monitor. It seemed like it was relatively easy to construct as well. So
yeah, well, that's good. Well, it seems pretty easy, and I mean, I like the work Bill does. So I think that this will be something worthwhile looking into. Because really, if you have a really long buffer, I mean, number one, your water quality benefits diminish, but your volume reduction and the amount of the area that's wetted when you have a rainfall event, a small rainfall event, is probably not using the whole buffer. So if this can help us to more, better spread it and more fully use the buffer that we have, that could be a good thing. But thanks for that feedback, Morgan. Okay, just a couple more here, and then we'll get to some more interesting stuff. I'd mentioned earlier vegetation, and I put this one in here. This is actually from the revegetation chapter, and I picked the sandy soil mix just for illustration purposes. Although normally we have a bit more clays in it, but this and I think this is a good seed mix for upland areas. I'm just not positive it's a great one for buffers because you have a mix of sod grasses and bunch grasses, and if you don't want to have to irrigate, I guess the question is will any of these really, can you get them with temporary irrigation to a point where there'll be a self-sustaining 80% kind of cover, or do we just need to tell people that if you want to have a good buffer for water quality, you need to irrigate it? So I just throw those out there as, again, talking points and discussion. But what experience have the folks on the call here had with non-irrigated buffers and native plantings?
Josh, you want to weigh in on this? I'm calling you out.
You sure are. Thanks, Jess. Grass swales versus detention basins, I think, operate a little differently, but suffer similar challenges, right? So like in detention basins, you tend to have longer residence times. And I think the challenge I see in those situations are we have, and this season is a perfect example, we have these huge gaps between storm events, right? So if it's non-irrigated, you would end up with these xeric species that establish in there because they're not, getting that their feet wet enough to have those more mesic species establish and survive. And then you get this 1-inch dump, and then you got 4 feet of water sitting over the top of it, right? And if that's sitting there for 72 hours, those xeric species that have established are going to suffer and possibly die, right? So with grass swales or buffers, you don't see that same measure of depth or residence time. But I think the concept still is effective for what we see here. And so it's an interesting conversation around irrigation versus non-irrigation, because you almost have to keep those mesic species alive in between these storm events in order for them to be effective during those the times that we really need them to provide all the benefits of grass swales and buffers. But when you talk to like Denver Parks and the game plan, and they're really looking at reducing irrigation, are the municipalities or project partners that are moving in that direction, do they want to keep grass alive for those in-between storm events? So that's I think a larger debate that needs to take place. But you raised some really interesting questions earlier around like the density of grasses and bunch grasses versus sod forming. And on Central 70, for example, we developed a seed mix that has a very broad spectrum of species from xeric to mesic to try and handle that. Whatever conditions kind of exist best for that area is what's going to establish, right? But when I look at like the detention basin around in my neighborhood, like they have like one species, right? And it seems to do pretty well. And so should we be really looking at a more diverse seed mix to try and accommodate the variability of conditions, or do we want to find like 1 or 2 species that we know are going to fill in and mostly survive everything that we have coming their way?
Well stated, Joshua. I think that's the debate, and that's obviously where your guys' input will be really good. And if you go to table A1, which is the upland seed mix for the loamy soils, that has fewer choices than this one, I think, by a few, but it's still a pretty diverse mix of bunching grasses and sod forming grasses. And so I think this is an area obviously for some more discussion and a great area for all the landscape architects to to provide some good input from their experiences on what really works and, and what densities can really be expected when depending on different seed mixes that are used.
Right. Well,
Andrew,
and we're sorry, real quick.
Go ahead, Josh. Go ahead.
One thing when we're talking densities, right, is also how many seeds per square foot are we putting down, right?
Yeah.
So, so if we're expected to get 80% cover, are we putting down enough seeds to make that happen, or because the NRCS has a very different opinion than some ecologists and landscape architects, right? So like Denver Park seed mixes have been increased to have about 120, I think, 130 seeds per square foot for their standard mixes, because you're not going to see everything germinate. The NRCS in non-irrigated wildland situations go as low as 20 seeds per square foot, right? You're not getting 80% cover with 20 seeds per square foot. And so really making sure that we have that balance correct, I think is where some fine tuning still needs to happen.
Good thoughts. Thank you.
Sorry, Jeff.
Did you have something?
No, Josh, you hit on it. I was only going to add that, and I think to a certain extent, the criteria allows for variable conditions, right, in terms of sandy soils versus loamy. But there's also maybe another factor, which is, for the most part, those mixes are attempting to replicate a natural area.
Yeah,
I'll say. And so in several instances, you're trying to replicate a natural area in a pretty unnatural context. And so as the image that Cassie showed, you might actually, and I can't speak to what species were in there. Cassie, you could probably tell me more, but there might be a situation where you have something like that in a context that's looking for something that might not be native.
Mm-hmm.
And so then there's a discussion about how open-ended a planting would be in a situation like that. And I think that applies to other conditions beyond grassy swale or grass swales. But I just want to throw that out there, and thanks, Josh, for hitting on that.
No, that's a good comment, and I think it is just that grass buffer may be an upland area, but it's not just any upland area. It's an upland area with a very specific water quality and hydraulic purpose.
Mm-hmm.
Well, good. Well, our intention today is not to solve all the problems of the world. It's just to identify them. So that's good information. Any other thoughts on this one before we leave it?
I'll just toss in. This is Jim. The backcountry swales, I think, is a good example of native rhizomatous turf-forming grasses that were used, and they filled in great densities. But we definitely want to avoid much reliance on bunch grasses. Really want to go. You can go native, but rhizomatous sod-forming, turf-forming grasses are extremely important, and all the research we've done with swales shows, in answer to some prior questions, that the density of vegetation and the full coverage is essential just for slowing the water down and getting it into the ground. And so we're definitely, supportive of these comments to get a good dense grass cover, more than other types of landscaping like shrubs with mulch. That would give a totally lesser performing buffer and swale than full coverage turf forming grasses. So we think the veg is absolutely essential to focus in on grass buffers and swales, and it sounds like that's what the input has been directing us toward, and we'll follow up on it.
Yeah, this will be good, and it may very well be that we can use some of the upland seed mixes in the re-veg chapter by just removing some of the bunch grasses. But that's obviously where we want input from someone who knows vegetation instead of just an engineer like me.
So
good.
Just jump in real quick. This is Cassie. In that picture, we used a monoculture of blue grama in the bottom of the swale.
Yeah.
And it is irrigated. So that's why it looks so lush and green.
Yeah, it did look nice. I was saying that didn't look quite non-irrigated to me, but it was
it's
beautiful.
irrigated. Exactly.
Yeah, well, it also works very well. I mean, and it's kind of one of those comments somebody posted earlier on the texting, is that it's convincing clients that you're going to have a better buffer and a better site and better performance if you do that. And hopefully as people start using more recycled water for irrigation, that'll be less of a hurdle to get over in some cases. But water's always going to be expensive.
Yeah.
I
love hearing the irrigation conversation here because I really think that it is important. And that's not just because I'm the one fielding a lot of phone calls of why isn't my grass growing? Why doesn't this look like the pictures? But I think it's a good conversation to have.
Well, good. Then we're barking up the right tree on this one. So that's good news. Okay, well, let's continue.
Kathy.
I know we don't have, what's that, Jess?
I just said thanks, Cassie.
Oh, yeah, no, definitely. Thank you for the input. That's really good. Okay, this next one, I'm going to stop talking in just a minute. The one other thing, and this would apply to the grass buffers and the grass swales are, and this is another area for feedback from the group, despite the fact that Right Water probably helped to create them, I'm not totally in love with the design examples of having, kind of just a completed spreadsheet to look at. I can see some utility in that, but I also kind of feel like either in combination with that or in lieu of that, it's almost, less of a black box if you actually step people through and show them how the different calculations fit together, which is hard to get from just looking at, a completed spreadsheet. But anyway, that I just want to identify the issue and ask what the group thinks. And then the other thing for the design examples is something that we actually discussed this morning with Jim and Jess and Holly and a couple other people on the call, which is the idea of trying to kind of pair up photos with excerpts from design drawings to really illustrate examples. So, it's showing something that an engineer has come up with on paper, and then it's showing what it looks like in the real world. And, and we also discussed a little bit this morning about not getting into the, nitty gritty engineering details and keeping things somewhat conceptual. But I always find when we can relate something that we have on paper to something that we can see in the real world, that's very valuable. So what does anybody else on here, does anybody use the design examples? Do you have similar experiences or different experiences? Or have you received feedback from people you work with on these? Does anybody have any input?
I think it can be kind of confusing seeing the design examples and the spreadsheets. It's a little bit confusing to know which you should use, and if you're not getting the same results, and also just convincing the jurisdictions to follow one or the other. I think it would be helpful if it was more streamlined.
I also like that the comment that Jesse showed earlier, just some of these graphic calculations or graphic illustrations that weren't so much in AutoCAD detail with a kind of defined parameter, but more so here's a bunch of different level spreaders, and it's more applicable in that sense.
Yeah, I think examples so people can visualize what you're talking about sometimes is super helpful. I think that's why we often get stuck on, just water quality and detention ponds, because we've all seen them, we know what they look like, there's nothing to guess about it. But when you say level spreader and everybody show me an example of where that's worked before, and it's hard to point to that. I think more pictures and criteria, the better, even if it's a drawing.
Well, that's the perfect segue. Can you all still see my screen? I pushed something and my screen changed. You all can still see the presentation?
We can see it.
Okay, good. I wanted to be sure I didn't turn it off. Okay, well, that's my segue into level spreader concepts. And what I have coming up here is I have, 8-10 slides that show just different concepts. And these are from Muller and from Stream, and some from the flood district. And I wanted to, give whoever sent me these photos the opportunity to discuss what we're looking at and let us know your experiences. So I can't remember which ones came from Muller versus which ones came from Stream. They probably worked on the projects together. So whoever sent me this photo, if you want to speak up and let us know about this level spreader I mean, for the edge of the parking lot going into this bioswale. What is this your photo, Jess?
To be clear, I sent you this photo, and this is not our project,
Okay.
nor are there's a couple others in there that we sent you, but
Oh, yeah.
I just like this image because it's a little bit, now this image has some issues regarding practicality and parking and wheel stops and those kinds of things, but I do like this image in that it provides for a way for water to enter this facility without focusing the flows. And that was really the only thing. I think, again, there are some other issues with it, but I was just interested to hear what people's thoughts are. We're so programmed to curb and gutter everything, and clearly there are challenges and benefits. So that's the only reason I sent that image.
No, and I think it's good. I mean, and I think there are ways you could solve the wheel stop issue without it really impeding the function of the level spreader if it were done the right way. But this thing's
yeah, for sure,
doing a good job. I mean, you don't see any real erosion, you know, on the treatment practice side of the spreader. I've just heard anecdotally from a lot of people that, and I think a lot of municipalities would probably say the same, is they don't like these kind of ribbon strips on the side of the road because it's, right, you know, safety or people driving off the road. But to me, in a parking area is a little bit different, where you don't have the live traffic and you have structured parking or you know, or parking space, let's say. But I like
it kind of takes a hint from Jim, the roads in backcountry, you know, that type of approach where maybe you'd have a gravel band right at the edge of the concrete band, those types of things.
Yeah.
Yeah, and I was curious if people had input on this, because it's I love the concept, but I think the wheel issue is important. I've seen really bad ruts off of the ribbon curb in certain applications, which really messes up the whole sheet flow spreading and is ugly and needs to be maintained. And so I think this approach is best solved with some of the wheel stop issues, but in a street, it's hard to do that. The gravel bands we've had mixed results with, because sometimes that gravel on steeper slopes can erode longitudinally with flow. And so slotted curb options on streets have some benefits to deal with the wheels. But do people on the call have any thoughts or experience on this issue of the wheel issue of getting off these ribbon curbs?
And I think, to be clear, sorry, Tanner, to be clear, I think you've got these in the right order, because it sort of sets up the slotted curb, which is your next image.
Yeah, you ready? Let's look at that one. That's gaps between, well, I don't think these are wheel stops because it's not a parking area, but it's a slotted curb. And a nice little rain garden. I mean, I think the one thing that the picture before this one and this one illustrates is that level spreaders aren't just for grass buffers and swales, you know? I mean, they're a great way to get inflow into a bioretention cell too without causing erosion. This one I think is from Portland, Jess, isn't it?
Yeah, I believe so. Again, this was not our project. It was just one of the better images. I actually have a good image of one of our projects, but it's all dirt right now. So this one's nicer looking.
Yeah, that's Portland. I can confirm.
Yeah, they're lucky rain. They get so much of it.
But
low intensity.
Ryan Wellington could probably speak to that one. But.
Yeah, I could talk about that if you really wanted to. Those are deeper than they're supposed to be. But one quick thought too is I have seen people use half wheel stops in kind of the previous one that has worked pretty successfully. So it's just one tire, and that was good enough, and it left pretty wide gaps in between. It can be done in a nice way, probably. So it's not quite slotted, but also not quite fully open either.
Yeah, you'd have more open area than not. And if you were to, I like that idea too. That could be a good workaround, because this one does not have a whole lot of openings when you consider the length of it. I mean, it definitely is diffusing the flow, and it's much better than having all of these openings concentrated in one place. But if you were to have, cut the width of these things in half, you could spread it out twice as much.
Yeah, and I would say even from just the last two examples, the number 9, it's that really, I would say, when it comes to the UIA, it's really a solid or very consistent, even distribution across the whole site.
Yeah.
The other one, I would, it is smaller, but I think getting the flows there it might be a little bit of a challenge. And so that balance there, I think you might see more runoff reduction from infiltration, maybe in something at the top.
And so one thing that we've done, just throwing this out there, go to that slotted curve one there, Andrew, number 10. One thing that we've done, if you can imagine on the back side of that slotted curve, it drops down to another flat pan, essentially. Do you have that Houston Lake one in here or no?
I don't think I have that one in
Okay.
here.
Well, at any rate, imagine that it drops down to another flat pan that's, say, 12 inches wide or something, whatever. So that allows, Brick, what you're talking about, then the water is not dropping into dirt, soil, planting media, mulch, and then creating all these little rills along the way. So it's the level spreader itself is actually after the slots. It's not the slots themselves. So that's just another way that we've done that. I'm curious if there's any comments on that as well.
Let me just share a different screen real quick, Jess. This is the one you're talking about, right? Your slotted curve.
Yep.
This is the
exactly.
document.
There you go. So there's a small drop below the slots, and then we just have a little pan essentially below it. And so it helps take that velocity out, and it also, you can actually see sediment in there. But on this one in particular, it also provides a mow band. So that kind of does a lot of different things, but just another way to envision how that would work with the slotted curve.
I definitely think that's the way to go. We have seen erosion at each individual slot when we've done slotted curves before.
Yep.
And Holly has a slotted curve detail in T0 that incorporates that secondary ledge.
Yeah.
Oh, good. Well, Holly, I know we're getting close to our time here. I have a few more, and I do have some comments on grass swales too, but I don't think we need to bother getting into those because my comments on grass swales are very similar to what my comments were on grass buffers. So I don't. Are we on till 3?
No.
Oh, we're only on till another 5 minutes then. Okay.
5 minutes.
Good. Well, then I'll wrap it up real quick, and let me just cycle through a few more of these, and then if there are any other discussion, this is one that's very in line with kind of how the manual is done, and the existing details in the manual, and that piece of concrete, which you don't want to have somebody stepping in this thing and twisting an ankle, which is one reason for that. This was one. I think this one's been installed for a good long time. I've seen pictures of this one for years. But this kind of also shows that kind of, the 1 to 3 inch issue, that if you do get good mature vegetation that goes through a number of growing and dying cycles, it can tend to build up.
And those two details are the same. They're different places. The top one's at Eagle.
Places, same type,
And
same
you can
idea.
see also that the Eagle one, there's a pan after the slot, whereas the one at Aurora Sports Complex does not have the pan after the slot.
Yeah, just an older design. This one's been around for a good long while. And then, you have some, this is an example just showing, obstructions that can happen versus one that's cleaner here. And the way this one on the right works, of course, is you have flow coming out of this, fills up the gravel, spills over, and then eventually comes over this curb in there. And this is a nice clean level spreader. You have some sediment retention that'll happen on the rocks and some back here too, and a good level surface. This was a neat concept with kind of multiple tiers in a row that I thought looked pretty cool. This is kind of the more traditional design that you're just looking at, and this is a beautiful picture, actually. Nice wet meadow.
That's that same Aurora Sports Complex.
Yep, Aurora, that's what I thought. I thought they were just two pictures from slightly different directions.
Yep.
This is, showing how it's used in a 4-bay. Again, they're not just for buffers and swales. They have a lot of applications. And then the last one that I brought up was just this with a couple of the slotted curb. And this, again, is not quite as wide as that other one we were looking at. And it looks like there's kind of a rock area down here, so that once this flows through, perhaps it even can fill up this area and then spread more evenly. Yeah, but that's what I had. And I have a few, like I said, a couple comments on grass swales, but they pretty much track with what my comments were already. So I don't think we need to spend the time going over those today. And I guess then I'll shut up as soon as I say that if you guys have any more thoughts on these slides or any more thoughts on this topic, please just let us know. We'd love to hear from each and every one of you on the call with, what your experiences have been and how, we can make things more user-friendly and more effective for water quality and runoff reduction. Thanks for letting me share my screen for a little while, Holly. I'll unshare it now.
Thanks, Andrew. Yeah, like Andrew said, we're really wanting to hear your comments. So if you have any additional thoughts on this, if we got you thinking about anything, or if you want to share anything, please just send me an email or give me a call. Other than that, I'll send out this recording and you will hear from us again when we've got more to share with you based on what you've given us. So thanks so much.
Thanks.
Thank you.
Thank you.
Have a good afternoon, everybody.
You do.